Hello everyone and welcome to another AP Computer Science video. This video is going to focus on some extra details that we haven't discussed in conditional statements. We've seen if statements that allow us to write code that is conditionally run, so it may or may not run, meaning we can potentially skip code or run a little bit of extra code if it's necessary. We've seen if-else statements that allow us to mutually exclusively write code, meaning that one piece of code or another will run but not both. And the last thing we saw was else statements, which are just an expansion of the concept of mutual exclusion, but we are allowed to make any number of mutually exclusive possibilities occur, where only one will happen. The last thing we had done is we had changed our code from a mutually exclusive example to one that was not individual. So the last thing we did here was we had made a bunch of else ifs and then we changed them to ifs by using our logical operators, and we saw the equivalency and how we can sort of make mutual exclusion occur if we have to with logical operators, but we also have the ability to make our own mutually exclusive statements with the else if command. Those are very useful things to do. And it's always about the context of what you're aiming for, and sometimes it's helpful to use it, sometimes it's not. Sometimes you must use it, sometimes it's optional. It's a matter of what your plan is going to be. So now we're going to continue real quick and finish up some different ideas that occur. So I'm going to make a new Java class in our control structures package just so it's a little bit easier to read our code so it's not crammed all together. So the idea what we're going to talk about today is called nested if statements. So nested conditionals, I'll put. And basically the idea is that, and this may have been obvious and you may have kind of seen this coming, but I want to be explicit about it, there is no limitation about what could be in the body of an if statement. What code could be in the body of an else? What code could be in the body of an else if statement? This would imply that if statements could have if statements inside of them, or else statements could have if statements inside of them, or any mix going as deep as we need to, as much nesting, which means like one thing inside of another again and again and again. There's no rule that says you can't do this many times or you must only do it once. No, there's nothing like that. So I want to see an example of how we could do it, first of all, just to be clear about it, and the fact that there are logical equivalents that we could use, and it's a matter of style, and certain times it's easier to manage one way or another. And so it's really a matter of what you prefer, what you think is easier. But we should be comfortable with both scenarios because, one, the AP exam will show us potentially code in both ways, and depending on when you're writing, maybe working on a project, sometimes certain styles of code click on our minds better. Sometimes it matches the thinking that we might have, the reasoning we might have in our natural language, and so we'll stick with one way. Other times we might think it's worth the investment of changing the structure to our benefit. It's purely a matter of the context and what we think is going to work out better for us in the long run. There's not often a definitive better choice, but we should be experienced with both. So I'm going to make a main like we always do, use my shortcut. And there it is. And now let's go ahead and come up with a scenario. My scenario is going to be this. We're going to take in two numbers. We'll use a scanner to let the user type in two numbers. And we want to ask a question. We want to say, well, if the first number is even, then we want to ask a particular second question. And if it's odd, we want to ask another question. So depending on whether the first number is even or odd, we'll ask for a second number and we'll ask a second question. Right? So I'm going to write out our scenario in notes just so we have them as a comment, and then we can kind of try to implement that. So we'll say accept a number from the user if the number is even. Then let's do this. So we'll say 1, accept a number from the user. That's our first step. And then we'll say if the number is even, our second step will be to accept a second number and ask for a second number, and then say if the second number is a multiple of 5 and 13. Well, not do 13. Let's do 5 and 7. And let's go ahead and do, then we will say display the message. And this is arbitrary. We'll just say huzzah. All right. Okay. So this is a good thing. And now, now back to the first question. If the number is odd, then we'll ask a second question. We'll say ask for a second number. And then if the second number is within the range of negative 75 to 150, inclusive, we'll say display the message. I don't know, we'll just say the word potato, and then otherwise, so display the product of the two numbers. So there it is. So there are several scenarios here, and we have to kind of mix and match them. If we ask ourselves, well, how many scenarios officially are there? So the first scenario is if the number is even, and the second number is a multiple of 5 and 7. That's one scenario. Another scenario is if the number is odd, and it's within the range of negative 75 to 150. A third scenario is if the number is odd and it's not within the range of negative 75 to 150. So for example, the number 192. That would be that third scenario. And there is another scenario, but we're not really coding for it, but it can happen. And I do it on purpose because I want you to be clear that it's not always necessary to have an else. It's useful and it can be something you might want to handle, but sometimes there's scenarios where you just don't want to actually handle them, right? So it really does depend on what we're trying to do. So that fourth scenario that we're not really talking about here is if the number is the first number is even and the second number is not a multiple of 5 and 7, which is a lot of numbers. And so in this case, we don't really talk about it. There's no else to this. Here, there's an else. The otherwise is essentially else to this sub-if statement. But in this case, there really isn't an else. So we're not that fourth scenario, is a possibility, but it's not one that we are coding to. And that's perfectly reasonable. It totally depends on what we're trying to do. And so maybe we care, sometimes we don't. And we want to see kind of the different code paths and how they can occur. But for now, let's try to do this, and we can always adjust things from there. So let's go ahead and do this. So let's go ahead and make our scanner, because we're going to read input from a human being. So let's go ahead and make a scanner. I'm going to call mine KB as always, because it represents the keyboard we're reading from. We use the constructor of the scanner, which is a special method that lets us build this in memory so we can use it. And then it connects it to the console, so we use system.in. There it is. We need to fix our imports because, again, this is code that while it exists in the Java library, it's not default. And so we have to make sure our code knows about it, so we can either type an import or have NetBeans fix it for us. I'm going to right-click, fix imports, or Control-Shift-I, or Command-Shift-I. And there it is, import java.util.scanner. So now we can use the scanner. Let us make two variables. I'm going to make them both just because I know that I'm going to use both variables, and I'm going to put them both outside of the if statements because one thing we have to recognize is that when we create variables in a scope, they only exist in that scope. So if we make variables inside of an if statement, they will only exist on the inside of the if statement, and if we think we may or may not need to use those variables outside of them, then they need to be declared before they are used in those if statements. That's important. In this scenario, we might not really need that, but it's a possibility, so let's just make it easier on ourselves and declare them ahead of time, just so we have access to them at all points within our if statements. Particularly the first number. The first number is the one that needs to exist before the if statements, because otherwise we can't potentially even ask the question. So I'm going to make the assumption that these are whole numbers, so I didn't really write that anywhere, but let's go ahead and make that assumption. So I'm going to use next int when we use our scanner commands. So I'm going to say int first num and int second num. So I've declared them both just so they exist. And now let's go ahead and read in the first one. We have to put a message, of course, because otherwise the user might not know to enter a number. So let's do our message. I don't use ln. Enter an integer value. Right? So here we go. And then now I can say first num is going to be equal to whatever they wrote in. So kb.nextInt. So I accept what they wrote. I store it as an integer. It's converted for me automatically, assuming they typed in something that can be converted. Okay, so we have our first number. Let's ask this question. So what we're going to do is we're going to use the nested if statement structure first, and then we'll write an equivalency, the exact same code, but without any nesting. And you can decide for yourself, do you think one way is better or another? Do you think we gain some advantage? Is one more clear than another? It's a matter of, often a matter of style. Sometimes it's helpful to be one way, but there's, again, no definitive best choice. So let's ask our question. So it's pretty direct in our English language, if the number is even. So if, how do we know a number is even? You think about it. When a number is even, it can be evenly divided by 2. So if we do the modulus of 2, modulus gives us the remainder of division. If we get 0 as an answer of the modulus of 2, then it must be an even number, right? So 7, if we modulus it by 2, 2 would go into 7 3 times, which would give us 6. There'd be a remainder of 1, so 7 is not even. But in the number 10, 2 would go into 10 5 times, and there would be no remainder, which would mean the modulus would be 0, so 10 is even. So if a number mod 2 is equal to 0, then it is an even number. So let's go ahead and write that. If the first number they gave us, modulus 2, is equal to a 0, and remember, equal is a comparison, not an assignment. We're not stating a fact, we're asking a question. And so if the first number is equal to an even number, then what do we say? Then we said ask for a second number and then ask a question about that second number. So here we go. Let's ask for that second number. So same thing. We're going to print out a message. I'm not going to use ln. Enter another integer value. And now we can use second num, and we'll say that it's kb.next int. Again, I'm assuming integer values. Second with a d num. And now we say, okay, we'll ask another question. If the second number is a multiple of 5 and 7. And so in fact, this is the same thing. When I ask if a number is even, we're just saying, is it a multiple of 2? So the logic will be the same, except instead of a 2, it'll be a 5. And then we'll do it again for a 7. So we will say, if the second num modulus 5 is equal to 0, that would imply that 5 went into the second num evenly with no remainder, and that would make it a multiple of 5. So 15 would be 0, 15 mod 5 would be 0, 35 mod 5 would be 0, and so on. And so that's one thing. And then, of course, we said the word and, so that would imply that we're probably going to use a logical. And now I'm going to point out we cannot do this. And as nice as it would be, it would be really nice to be able to write something like this. And 7. Right, if both of these things could happen, but 5 and 7 is not a logical statement. We remember our order of operations says that our comparisons must happen first, and so this is going to say 7 equal to 0 is false, and then 5 and false would not make sense. This would not be, or we do the modulus and we would get a number, and this would return a number. A number and a boolean is not, it cannot be connected with a logical operator, so this doesn't make sense. So what we're forced to do instead is kind of rewrite the same question but with the 7. So instead we're going to say, is second num mod 5 equal to 0? Is second num a multiple of 5? And is second num mod 7 is 0 equal to 0, which would say is it a multiple of 7? So is it a multiple of 5 and 7? And so the first number that is easy to remember that's a multiple of 5 and 7 is 35, because that's the multiplication of the two numbers. And so 70 would be another number that would be a multiple of 5 and 7. And so if this is true, then we can do something. And we said to display a message is to print the word huzzah. All right, so let's go ahead and do that. And there it is. And then that's it, because I didn't have an else, so there's no need for an else condition. There's no mutual exclusion. There's no possibility. Now, it's possible that we'll get into here in this if statement, an even number, the first one, and then this one is false. So our program may write nothing, may not print anything at all, because this might be true, the first if statement, and the second one might not be true, and then we'll get to this point where this will be skipped, and then it ends. And then if there's an else, we're going to skip the else, because you don't do the else if the outer if was done. So an even number could potentially not print anything at all. An even number that is a multiple of 5 and 7 could give us. And so in fact, the number 35 will not print anything, because so immediately 35 is not even, so it won't show up here. The number 70 would print both, because 70 would be an even number, and then 70 would be a multiple of 5 and 7, and then we would see huzzah. So we can test it with that number 70 and see that's the case. If we do the number 36, it's an even number, it's not a multiple of 5, and it's not a multiple of 7, so they would not print. Let's say the number 28, it would be an even number. It is a multiple of 7, but it's not a multiple of 5, and therefore we wouldn't print anything either. So those are different numbers we can test with. Now we said, if the number is even, and then we said if the number is odd. So this could be another if statement. So we could go right here and do another if statement. But we have to ask ourselves, is it necessary to ask a question, a separate question? Is it odd? Or do we hopefully recognize that if the number is not even, what must it be? Odd. It's not possible to be even and odd at the same time, right? Maybe in terms of code, if we did 0, then 0 mod 2 would be 0, and no, 0 would be an even number because 0 mod 2 would always give you 0 as an answer. It couldn't give you 1. So then even that would be caught in this first if statement. But there's no need for a second if. And now you might ask, does it matter? Can I just ask to put that second question? The answer is you can. But if we're talking about efficiency, if it's possible to not ask 2 questions, go for it. Right? If you can ask if it's even, the implication is that if it's even, you're going to do that code. There's no need to ask if it's odd. And likewise, if it's odd, you might have to ask both questions, but if we're lucky, we won't have to. Right? It's one or the other. And so the idea is that we want to be able to be as efficient as possible. And so in my opinion, instead of asking a second question that outright asks if it's odd, I think it's a better choice to do an else. Because they are mutually exclusive. Either you are an even number or you are an odd number. It's not possible to be both. So this is a good situation where it's naturally mutually exclusive. So let's enforce it with the else statement. There's no need to ask a second question. Now I could do this. Else if first num mod 2 is equal to 1. Or I could also maybe write not equal to 0. Those are all equivalent. But again, it is totally unnecessary to ask this question because if this question was false, this one, it's clearly going to be an odd number. If it's not even, it must be odd. So I would argue we don't even need the else if. We'll just say else. And again, you decide what you think is appropriate. In general, when it comes to projects and grading, I will not be overly picky about those things. I think that unless it's a blatant, total misuse or redundancy, then I generally would say, okay, you can be a little more expressive if you feel that's necessary. But hopefully as we get more comfortable, we can spot these things and say, it's not necessary, why waste the time? So here we are in our second condition. So I'll put a note, though, that says the number must be odd, right? Because it couldn't be otherwise. If it wasn't even, it must have been odd. And now it says, okay, well, ask for a second number. And then we can ask a question. So here we go. Let's ask for the second number. I'm going to copy and paste this because I'm lazy. And there it is. And notice they're both using second num because it was declared. So it'll either be assigned here or it'll be assigned here. So there's no worry that it'll ever be blank. At some point, we're going to store a value in second num. And then it says, if the number is within the range -75 to 150 inclusive, display the message potato, otherwise display the product of the two numbers. So here we go. Let's ask that question. How do I know it's in the range from -75 to 150? So we're saying inclusive, meaning that -75 is a possible value in the range, and 150 is a number. So let's say if second num, and so since it's from negative to positive, that means we can be -75, -74, -73, -20, -1, 0, 10, 15, up to 150. So if we're greater than or equal to, that's the inclusive part, -75. And then again, it uses the word and, or to, so this implies that we're doing both. If we drew a number line, we would color it in the whole area. So that would imply a logical and. Both statements must be true for this to be true. The second num is less than or equal to, that's the inclusiveness, 150. Then we must be in the range. And so again, for example, if we did the number -100, right, that's true that it's less than 150, but it's false that it's greater than -75. Therefore, the whole statement is false because it says both must be true. If I gave the number 199, it'd be true that 199 is greater than -75, but it would be false that it's less than 150, and therefore the whole thing would be false. The number 22 is greater than -75 and less than 150, therefore that would fall in the range, which makes sense if we drew our little number line. And so if this is the case, then it says print out the word potato. So let's go ahead and do that. There it is. And then out here, we have an otherwise, and often otherwise is the same as saying else. And so in English, we might say otherwise or else and things like that. And so then we says display the product of the two numbers. So that's an easy one. So we can just do else. And here it is. And we'll say display the product of the two numbers, and I'll say product. And again, the words don't really matter. And then the multiplication is going to be, and I'm going to put it in parentheses, even though it's not necessary, because the multiplication will happen before the addition, so concatenation will not occur. But I'll just be explicit and do the multiplication, and we'll say, and I could also put it in a variable. I could do the multiplication if I really wanted to. So maybe I'll do that instead. I'll say int mult is equal to first num times second num. And then I would put mult in my little message. And there it is. And so here's a if statement with the nested if statement inside of it, an else with the nested if else inside of it. And again, there is no limit to the depth that we could write. If we're really technical, maybe there is an actual limit, but it's probably gigantic and you could have hundreds of nested ifs. Now I'm going to say the more nesting you do, the more complicated the logic is and the uglier it becomes, and the more difficult it is to diagnose if something is wrong. And there's many, many pathways. But we should recognize it. So that's one danger of doing nesting, but the advantage that we may gain is sometimes worth it. So this is a very light leveling. This is not too much nesting. This is pretty reasonable. But we should just be aware that nesting does occur, and we could express things in this fashion if we decide to. And that's it. So let's go ahead and test this a little bit, and let's see how it goes. I'm going to save. I'm going to right-click and run my file. Let's see. Here comes our output. There it is. Enter an integer value. Let's put an even number. Enter another integer value. And so let's go ahead and let's do that 70. I claim that we should see huzzah because 70 is both a multiple of 5 and a multiple of 7. And there it is. So let's run it again. I realize now that I might have been talking in a mistaken fashion before because I was considering first num. The second number is totally disconnected from the first number, so whether the first number is even or odd is irrelevant to the factoring of the second number. So that was my mistake, the way I described that before. So let's go ahead and put another even number, 34. And now let's go ahead and put a number that is not a multiple of 5 and 7. So I mentioned 28 is a multiple of 7 but not a 5. So we should see nothing. And there it is. The program ends because this is false, so we skip this code, and then since we're in the if, we skip the else. We hit the end of the else. We hit the end of the program, the main, and it ends. So that's why we saw no output beyond our entering. So let's do one more. Let's go ahead and do an even number, 30, and let's do 25. Same thing. It isn't even. The first one is an even number, but the second number is only a multiple of 5. Therefore, we don't see anything. Now let's test the else and the two different if-elses. So let's run this. So this one is if it's an odd number, so 71. And now the second number, if it's in range of negative 175 to 150, let's pick a number inside. So I'll go ahead and pick 0. But actually, let's not pick 0 because if we pick 0, we're going to get 0 as our multiplication. So let's do like maybe 2. 2 is in range. So we should get our answer as 142 because 2 times 71 is 142. Oh, I'm sorry, I'm confused myself. I'm in range, so we're getting potato. It's out of a range that it would be a problem. So here it is, potato. Yeah, because this one was odd, and then the second one was in range. Let's run it again. And let's do the same thing, 71. And now let's put negative. Ooh, this is going to be a gigantic multiplication because it's got to be either less than negative. It's going to be either a big negative number or a big positive number. Let's do 151. Actually, no, easier, 200. So it'll be like 14,000 something. 14,200. And there it is. And we see that, again, it was true that it was odd because this was false, so we immediately went to the else. We asked for a second number. 200 is beyond the range of this, so this is false, and we jump into here and we print the product, and that's how we get our output. So that's all I wanted to cover in this video, to recognize that if statements and else's are very useful. I do want to now show the equivalent of these with logical operators because it is possible to show an equivalent. So we'll finish with that, and we'll see that there's another way to write this whole system. So here we go. And this one's, in my opinion, this is a better choice than nesting because it's easier to recognize all the individual possibilities. This one says, okay, if we're going to do no nesting, then we need to recognize when conditions are true. So one scenario, so how many different possibilities are there? One scenario is if it's even, and this is true, and this is true. So we're going to have 3 logical statements. So here we go. If the number is even, so if first num, and now the problem with this is it's harder because now we have to ask for this first and second number at the same time. So this relies on first num existing. So this might be already there, but we have to do second num. So if first num mod 2 is equal to 0. So I'm going to comment this out temporarily to make this a little bit easier to deal with. So it's not exactly the same because this requires us to enter both numbers one after the other. And we'll say second num, oh, let's print out our message. I'm going to copy this. Here we go. There it is. And we'll say second num is equal to kb.nextInt. And now we can ask if this first num is equal to 0, and because if, think about it, if you are in the sub-if statement, what are we saying? That this was true and this whole component was true. So I'm going to copy this part, and the reality is this is what we're actually saying. Now, do I need parentheses around this? No, but it might make it easier to recognize that there are 2 distinct options. That the first one was even and the second one was a multiple of 5 and 7. So that's one scenario. And what did we say we would do? We would print out the word huzzah. So that's this printing right here. So that's one scenario. Another scenario was that it was odd. So now here, to express that it's odd, I actually do have to write the formula. So I'm going to put it. I'm going to say it's not equal to 0 or it's equal to 1. So I'm going to put equal to 1. So that tells me it's odd. And because now there's 2 possibilities, it's this one. So I'm going to copy. This is one possibility. So here we go. And I'm going to put parentheses again because I believe that it makes it a little bit more clear. So this is one possibility, that it's odd and it's within the range. So if it was odd and it was within range, what did we say we had to do? We printed out the word potato. So there it is. And what was the third possibility? It was odd and it wasn't in range. And so now here's the thing, because the else was convenient and it didn't have to be expressed the opposite of this, unfortunately, if we want to make it without the nesting, we must express the opposite of this. So we have 2 choices. We could find the equivalency of this, which would be what? Being less than negative 75? And, or sorry, not and, or, so here's what De Morgan's law could help us, because what is the exact opposite of this? We could put a not in front and we could push it in, or we can just put the not in front. So I'm going to go ahead and put the not in front first, and then we'll express it in a different way. I'll go ahead and say not this whole thing. So now I'm going to be lazy and just copy this part. So not in this range, right? If this is true, this is in the range, then the negation would be the not in that range. And so here is the third choice, and in this choice we said get the multiplication of the 2 and put it here. So I don't need this part right here. And so this is, and then of course there was a 4th scenario we mentioned, but that 4th scenario, no printing occurred, and so that 4th scenario could happen, and we might skip all 3 questions, right? The 4th scenario would be it's even, and we're not a multiple of 5 and 7. So that scenario is kind of hidden behind the scenes. It's an implicit scenario because it's not asked about directly, right? And so is this more clear? I don't know. And so now the last thing I'm going to do is I'm going to say, can we get the equivalent of this just so we know what it means? And so I'm going to put it as a note here. I'll put De Morgan's law says, and I'll be copy this. And so now again, De Morgan's law would say we can push in the negation. We have to negate each individual statement and flip the symbol. So the negation, or the opposite, because negation means opposite, of second num greater than or equal to negative 75 would be second num is strictly less than negative 75. So that if we drew our number line, it's actually 2 lines. One is not including, it's an open hole of negative 75, and then going to the right. The flipping of the symbol would be or, and then the second would be second num is strictly greater than 150. I mean, this should have been 150. That's a mistake on my part. Did I actually screw this up? No, I just must have somehow deleted it. And so here we go. So greater than 150. And so that's De Morgan's law, and it would imply that these are the same thing. So the negation is gone. So it wouldn't matter which way you would put it, but the reality is, to be clear, I think this one is the more clear one. And just to kind of give us a proof that De Morgan's law is absolutely correct, if we had left this as an and, then what we'd be suggesting is that a number must, in order for this to be true, a number must be less than negative 75 and greater than 150. That's not a possibility. There is no integer value in the universe of integers, the infinite set of integers, that is both less than a negative number and greater than a positive number. There is no number that can do that. And so therefore this is an impossibility. It would always be false, which means it's a worthless, essentially logical statement. And so this is why it's an or. De Morgan's law would have told us to flip it, and if we didn't, then we wouldn't be applying it correctly, and then we would have a problem. And then we would have a subtle semantic bug that could cause problems. We would say, how come it's never happening? Is it a coincidence, or is it a flaw in our code? And it's a flaw in our code whether we spotted it or not. And so there it is. So you have to ask yourself, which of these possibilities is more clear? The nesting or the combination of statements with logical ands? They mean the same thing. All four scenarios are covered in both. But in my opinion, the nesting is the easier to understand because it takes it a step at a time. Right? There are situations where combining them is helpful and easy to read. I don't think this is a situation where it's that useful. And of course, we only have one set of nesting. Now imagine if we nested another if statement in one of these if statements or one of the else's. Then they would amplify. In fact, as you nest, you basically multiply the possibilities. If I put an if-else inside of this else, that means there's one possibility. The second possibility, if this is true or this is false, that's two possibilities. The third possibility is when this one is true and this one is true. The fourth possibility would be when this one is true, the first one, and this one was false, which means this one would be true. And then within this one, there would be a true and a false. So that would be more. You would end up with a lot more possibilities, and it would get ugly really, really fast with this writing. As the nesting is just nested, but so each if statement is kind of clear and separated, even though they're connected through the nesting. Here, you'd have to use logical ands, and there would be way more else ifs, and they're all very expressive and wordy and not great in my opinion. So you have to get comfortable with these ideas. You have to choose a style you think. Again, there's not one right answer. It's a matter of comfort level and understanding of what your intent is. Which one is more expressive to the meaning you are trying to code for, is what I would say. So I'm going to end the video here. I hope to see you all in the next video.